Alright, so in this video I dive into my Borg & Beck. It is an HKF 1009 Sprinter van single mass flywheel kit to go on this 716. It's stamped with a 648, but the sticker says it is a 658. Alright, so let's walk over to that single mass flywheel kit. Alright, so here it is, and in this video I will break this down and do all the measurements on it. I'm also going to go through the flex plate. There's the 606 back there, the 648 is right here. We're going to look at the crank stick out on both engines, but the primary objective is to get my main vehicle running, which has a 606 in it and that transmission I showed you earlier. So originally I was going to use the 765 Sachs pressure plate for the BMW M series M5, and also the Audi TT clutch disc had the right splines on it, but we're going to look at that as well. It actually measures up pretty close to the one that came in the kit. So I will put a blog on the BenzForce website. I did quick measurements on this for this video, but I am going to remeasure everything, and that blog post will have my final measurements and what I would machine to in terms of a single mass flywheel kit that I would produce. So let's walk through, and hopefully this gives context into what I'm going to call each dimension. Alright, let's get started. Alright, so there's a ton of measurements I want to take on this, and I don't need all of these, but if I want to be able to produce a single mass flywheel at a later date, then I would rather have more information than I need than less. So it's important to note that this is a cast piece and parts of it are certainly machined, but because of the casting, there's a variance in the measurements. So I tried to take an average of what I was seeing and use that. So let's first talk about the crank reset, right? So on the 606, I had 11.8 millimeter depth from the face of the crank to the the full stick out, and the 648 was 10 millimeters. So when I measured this, I had a recess of 10.2. Okay, so that's obviously a problem. Given how thick this thing is, I believe there's more than enough material to take off a little bit of that, so that's not a concern. A lot of people will grind the backs of their crank, and it would just be nice to have a simple, easy bolt-on solution. So next we have the timing gear. So all of this would need to change to use on a 606. And some vendors will have you cut off your 606 or 648 gear and put it on, and that's not a difficult thing, but it would just be nice to have something that's simple and bolt on, and I can cast it in, and cast flywheels that are machined should not be too expensive anyways. Alright, so here the width, we got 28.25. Of course, my measurements that I do during the video are going to be different than what I had previously because it depends on where I'm taking it from with the casting. The timing ring, that's what I'm calling this piece right here, to the face of the ring gear I have at, this says 21.06 in this place, and I have 21 written down. Okay, so from the crank face, so for this, I measured this distance, and I got 35.22. The ruler is 28.5, so that leaves me with 6.72 millimeters difference between this plane and this plane. So the ring gear width, I have 12.75. And then for the timing gear diameter, I have 272.7. Okay. And then the ring gear, I got 306.82 written down. And you can see it vary as we move around. Okay. So that is just about everything on the back side. Now I'm going to flip it over. I'm going to take some measurements, and then we'll come back and we'll go through what I measured and what it means, or what my terminology is that relates to the measurement. Alright, so let's roll through all these measurements. First, of course, is the diameter. And I got 285.85 as an average. If we roll it around again. The important thing here is also you got to make sure that you are truly straight, right? There we go. Alright, I'm calling this the clutch cover lip, basically. So the depth of that to the ring gear, I got 25.25. There's some variance if you come around. Okay, the lip width, I got 21.65. And again, tried to measure multiple places. We got the pin diameter, which is 5.95. That varies as well. Not very much, though. Okay, the lip to the clutch plane. I don't know if it's my expectations, but I would think that this would be a lot more uniform. So I get 7.75 is probably the average if we were to go around this. Okay, so from the lip to the bearing. So again, I got my 28.5 millimeter wide ruler here. I'll come down. I get 50.6 millimeters. Then I subtract that, so I get 22.10 millimeters from this plane right here to the bearing face. And if I do the same thing to the bolts, then I get 61.65. Subtract the ruler, and I get 37.15. So right away we can see some things we're going to have to make on the backside, some changes. We're going to have to make the recess bigger. I would like to see this machined a little more consistently. And next we're going to look at the clutch cover, and we will see how the pins and the bolt patterns match up with the Sachs 765 BMW cover. Alright, so this is the first time I've actually pulled the Sachs clutch cover out of the box, and there's an obvious problem right off the bat, and I don't know if it stands out to you, but the mating surface is actually below the clutch cover. And the single mass flywheel kit, not only is it beat to hell like the Vallejo kit was, but it's above. Right, so that's going to affect the clearances of the disc itself. So let's just go ahead and measure everything, and then we'll talk about that. Alright, so the first was trying to get the diameter of the clutch cover, and there's not really a good way of doing that, so I tried to go from the stamped steel piece here. Fortunately, these are massive calipers. And went across like that, and on the BMW I got 288. Again, I just averaged these out, and then 280 on the Borg and Beck, I think it is, cover. Then I went from the face to the mating surface. Alright, so if we measure, and again, it's stamped, and the Sachs actually has recesses, so I went from the highest point down to the clutch cover, and then I got to subtract 28.5 for my ruler, and on this it is 6.35 millimeters below. And then in the Borg and Beck, you know, basically I did the same thing, and it is 4.69 above the surface. Okay, then I wanted to measure from the fingers to the mating surface. So in this case, I'm using my table as the other plane, and then I can just come up and measure across. Alright, so this is 72.65. Yep, 44.15 from the fingers to the surface, and then I did the same thing on this side, and it was 45.4. So what does all that mean? I really have no clue what the hell that means. This is a big concern to me. We'll look at the clutch disc next. 8 millimeters. This is the Borgenbeck that came in the kit. Again, the surface is all shot up. It'd be nice if they could at least put a piece of cardboard between the two. Alright, so let's look at the flex plates quick, and then we'll sum things up. Alright, so let's start off with the diameter. Alright, so if you measure the overall diameter of this thing, a 648 will come in at 324.6, and then the 606 flex plate will come in at 306.6. So a huge difference there. Next, I measured the width. The 648 comes in at 12.45, and the 606 is right around 12. Okay, then I did the ring gear to the inside of the timing, and on the 648 I got 10.25, and the 606 was 12.5. Okay, then I went the height of the timing mark itself. So I measured like that. Okay, so the 606 was 9.7, and the 648 was 7.2. And that does not look right. Let me double check that. I got those backwards. So this is 9.7 on the 648. Oh, I just read it backwards. Yes, 9.7, and then the 606 is 7.2. Okay, so next we go to the width of the timing marks. The 606 here has a 5.25 average. I'm actually going to call that 515. And the 648 is 6.6. Okay, the timing pattern, we have 6 timing marks on this, and this is 60 minus 2. So 2 of those have been removed. And then from the face of the crank to the far side of the gear is, on the 648 here, it's 22. And then on the 606, it's 25.9. So huge differences, really, the diameter being one of the biggest ones. So they are not as interchangeable as I thought. All right, so let's kind of sum things up here. If we look at the 606 flex plate and we look at this, other than the timing, it's pretty spot on. So even from the crank face to the ring gear is about the same. I mean, there's a little bit of variance. I can't remember off the top of my head. I think it was 14 or something like that. The big disappointment is, I think, the machining that needs to be done for the clutch cover. And I don't think I can get that done in a reasonable amount of time. Alright, so this video has actually been made a couple times. I've gone through and I've measured different parts at different dates, and just trying to piece it together as I have time. But really, in the end, I need to get the car running, and I want a decent solution. I don't want to just do a hodgepodge of parts. So I think the real answer is for me to run with this Borgenbeck kit. And again, I don't know if you saw in the video, it really pisses me off that they can't package this stuff better because it's all dinged up. But I'm going to roll with it. The goal is to put a different 606 that's built with my own rods and NPR pistons and everything in it as soon as those parts become available anyways. So this should last a while. I don't need to get on it. It's a commuter car. So I'll roll with this, but I want to design a better single mass flywheel that is bolt-on and has an easy to find and cost-effective clutch cover and plate that will hold some decent power, right? So we're not after, you know, massive quarter-mile power here. We're after really strong streetable use. I know it was a long video, so thanks for sticking in there and thanks for watching.